Today we are going to discuss about vehicle along a horizontal circular track. Can you see this picture? This picture is the clear picture of vehicle which is moving along a horizontal circular track. Which are the forces help this vehicle to take a circular turn while moving along with such road? Let us discuss in detail. We are in the chapter rotational dynamics. In this chapter, we are going to study about the reason and the responsible forces for the rotational motion. That's why the name itself shows it is a rotational dynamics. In the case of vehicle along a horizontal circular track, you can see in this picture that vehicle is moving or taking a turn along a horizontal circular track. Which are the forces responsible for this safe turn of this vehicle? If you are considering R be the radius of the horizontal circular track. So if you consider R as the radius of this circular track. Okay. So which are the forces acting on this vehicle? Why this vehicle is taking turn along a horizontal curved road? The first force which act on that is due to its own weight, that is mg, that is vertically downward. So you can see the weight of the car, we call it as mg, and it is acting vertically downward. Normal reaction n vertically upward, that balances the weight mg. Yes, unless and until the normal reaction balances with mg, no object can stand on the surface or on the ground, you can say. Yes, so N and mg are always equal and opposite, and N is the force that is called normal reaction, always perpendicular to the surface of the object. The third one and very important one is force of static friction between road and tire. Yes, the frictional force acts or come in action and plays the role of centripetal force, and it is between always road and tires. Remember, while any object taking turn along with a circular track, what will happen? There are two forces which are responsible for the circular motion. One is centripetal force and another one is centrifugal force. Centripetal force is always along with the radius and always directed towards the center. And the centrifugal force is equal and opposite to the direction of this centripetal force. So you can say this is centripetal force, and the equal and opposite force which acts outside of this direction, that is centrifugal force. So these are the two forces which are responsible for the circular motion of any object. Remember, other forces always plays a role of centripetal force. Here, which force is acting as a centripetal force? That is static friction. That is a force of static friction between road and tire. This force of static friction prevents the vehicle from outwards slipping or skidding. Yes, while vehicle is taking turn along a curved horizontal road, it has to uh, take a safe turn by avoiding slipping and skidding. While working in the frame of reference attached to the vehicle, it balances the centrifugal force. I already explained you the here force of static friction playing a role of centripetal force, and who balances with this? Under the frame of reference, the centrifugal force balances with the centripetal force. You can see this picture, which is I have taken from your textbook, and this is the imaginary picture to make you give the realistic effect to understand the concept. From the figure, what you can see, if you are taking the figure 1, which is from your textbook, I have taken from your textbook, consider this figure I am talking about. So, from the figure what you have understood? mg is equals to n. See, the mg balances with n. And what is force of static friction? We already studied. It is nothing but it plays the role of centripetal force. So what is centripetal force formula? It is mr omega square. And you also might have seen centripetal force can be written as mv square by r. So you might be asking how two formula came. So you might have know the relation, that is v is equals to r omega, where r is the radius of the road and v is the linear velocity and omega is a angular velocity. By using this formula, if you substitute here v value with the r omega, obviously you will get this value. So they are interrelated. So both the formula are nothing but they are the formula of centripetal force. So call it as equation 1. Where we already studied in the 11th standard, Fs by n is nothing but mu s, where mu s is the coefficient of static friction. This coefficient of static friction gives you the value with which the vehicle has to take turn. Means this gives you a limit of the speed. Now, for a given track, radius r is constant. Obviously, if any vehicle moving along with any road, the radius from the center to that road, it is always constant. For a given vehicle, if you are considering a fixed vehicle, you are talking about car itself, if you are talking about any vehicle instead of car also, the mg is always equals to n, as both they balance each other. That is also constant. So, what is remaining now? See, I want to tell you one thing here. Here, what we have seen, r is constant and n and mg also constant. Here, which force is remaining factor over here? That is Fs. What is Fs formula? That is mv square by r. As you can see, the v, if you are increasing v while taking a turn, the force of static friction also increases, as Fs is playing a role of centripetal force. Try to understand the concept. And centripetal force is nothing but mv square by r. So, if v increases directly, what happened? The Fs also increases, as they are interrelated. So, the speed v increases, the force of static friction also increases. So, what will happen? It depends upon a driver who is riding a vehicle, because the speed of the vehicle depends upon the driver. It's up to driver whether he is going to take a car with a full speed while taking a turn or a minimum speed. But remember, here static friction is not fixed in such case. What happens if the road is wet? Obviously static friction will become less. If any oil spill is there on the road, then also static friction becomes less. But we are not considering such a cases. We are considering only the normal case, that by assuming this road is dry. While you are assuming this road is dry, so Fs we have to measure, or we have to calculate the value of Fs with the maximum. Means we have to find out the maximum velocity with which this vehicle can take a safe turn. So for that purpose, by avoiding the cases such as the road is wet, or whether the road is there are some oil spills on the road, by avoiding such a cases, we are assuming that road is dry. So we have to consider Fs has an upper limit, that is Fs maximum, that is mu s n. Here also in equation 2 you can see Fs is nothing but mu s n. We have already studied in 11th standard. where mu s imposes the upper limit to the speed v. So the mu s imposes means the value, the calculation of mu s gives us the maximum speed of this velocity. So what to do now? To find that maximum velocity from equation 192. Here we have taken a mu fs as a mu r omega square and mv square by r. So what to be done? If we divide with the n, if this fs is divided with the n, try to understand. So n is nothing but mg. So this factor should be divided with the mg, and this factor also divided with the mg. So get cancelled. You left with r omega square by g, you can see here. And here also get cancelled and you left with v square by rg, you can see here. So this is, we call it as a equation 1. And also we know that the fs by n is nothing but mu s, that is from the definition of coefficient of static friction and called as equation 2. Now what will happen if you consider 192? If you consider 192, what is fs by n? Fs by n is nothing but mu s. And what is fs by n is also equals to v square by rg. So if you combine all these things, can I write fs by n is equals to mu s and is equals to v square by rg. And here we are calculating maximum velocity with which the vehicle can take a turn. So we have to give here suffix max. That will indicate that is a maximum velocity of the vehicle. Therefore, maximum possible speed Vs is nothing but if you solve this by for v square, if you solve this for v square, I will show you v square. Solving for v square means what? You are keeping v square one side, it is v square max is equals to nothing but it is mu s into rg. You have to just cross multiply. So this rg I multiplied with this mu s. So it becomes v square equals to mu s rg. If you remove this square value, then what will happen? Just my RHS should have a square root. So this is the final expression of maximum possible speed of this vehicle with which it can take a turn, that is nothing but under root mu s rg. That's it.